The TypeDesigner is a quick and easy way to build your own models and libraries in SimulationX without requiring extensive knowledge of Modelica. The graphical interface walks you intuitively through the process. In this tutorial, we'll demonstrate by building our own custom element. The TypeDesigner can be opened by right-clicking on the SimulationX icon in the library bar. Create a new package to generate your own folder in the library bar where you can save your custom elements. Typically, libraries are saved as a directory to manage the code of each element separately, for instance using version management software. But the option to save the entire library as a single file is available, making the library easier to distribute. Enter a name and a comment for your library. With default settings, the comment is what will be visible in the library bar. If you'd like, draw an icon. Then press Finish to create the library folder, which will appear at the bottom of the library bar. Now right-click on your library to create a new model. The other types of model elements, such as functions and connectors, may also come in handy when you're developing your own library. For now, select the Model option. It's recommended to save model elements as individual files to be able to use version management on each model rather than on the whole package. Add a name and a comment for your element. Then let's draw a very simple icon and move to the next step. We'll create an example of building your own fluid resistance element for the pneumatics library. Each step in the element design process can also be accessed through the menu at the left of the TypeDesigner. Connectors can be added by finding the pneumatic port in the drop-down menu and pressing the button to create new ports. If the pneumatic port isn't showing up in the drop-down menu, make sure the pneumatic library is loaded by dragging one of its elements into the modeling area. The placement of the ports on the icon can be adjusted by dragging them to the desired location. Feel free to change the name or comment of each of the ports. The Base Types tab is where we can add any elements that should be inherited by the model we are now building. For our pneumatic resistance, we don't need this. Under Components is where we can add parameters, variables, curves, data records, or even links to external databases. I'm going to add one parameter to represent the flow area and one result variable to represent the mass flow rate. I'll name the parameter A and set its comment to be the flow area. Be sure to set the physical quantity so that you can choose the units you want to use in the parameter dialog later. It's good practice to have a default value for your parameter. Now I'll name the variable m dot and add the comment mass flow rate. I'll also set the physical quantity. For variables, you don't need to set an initial value. If you do, that information would only be used by the solver if it needs to use iteration to find a solution, in which case it would take that value as a start value. Moving on to local types, sometimes there are situations where we may want to define an enumeration or a function or some other class of element that would only be used within the model we are building. The Local Types tab is where you can define those local classes. Regarding imports, importing Modelica libraries extends the name lookup so that you can use shorter name references in the code. Before entering the model equations on the Behavior tab, let's look at what we've done so far. We can see that the TypeDesigner has been generating Modelica code in the background. Pressing Finish, we can take a look at our partially finished element by dragging it into a new model. We can double-check the port names, as well as open the parameter dialog to see the parameter and result variable. Double-clicking on the element in the library bar reopens the TypeDesigner. Now let's add equations. We need to add an equation for our result variable, as well as for certain variables in the pneumatic ports. First, we'll write the equation for m dot. I'm going to write an equation in which the mass flow rate is dependent on the fluid density, the flow area, some coefficient that I will set to 0.01, and the square root of the pressure difference across the element. Autofill helps to find the right port variables. Modelica equations require a semicolon at the end. To understand which port variables require equations, we can look at the SimulationX documentation for the pneumatic port. The basic concept is that the connections are the capacitive elements of the network, containing the differential equations for the state variables and the calculation of the fluid properties. Resistive elements, such as the one we're building, calculate the flow variables based on the states at its ports and other inputs. so we need to write equations for the flow variables mass flow, specific enthalpy flow, etc. Assign port 1.m to be equal to m dot, and note that a positive sign denotes flow into the element. Set port 2.m to be equal to negative m dot. Here the negative sign denotes flow out of the element. We'll also need to define the specific enthalpy of the flows leaving the element. For this basic demonstration, I'm going to simplify this part with the assumption that the inlet of this element is always port 1. In that case, we can set both port 1.hflow and port 2.hflow to be equal to the specific enthalpy of the fluid in port 1. We can now view the finished Modelica code. It's good practice to add documentation to your element, which can be done using the editor. Finally, the Security tab enables you to set the protection level of your element code in case you want to share it with third parties. Here it's possible to set a password for usage and/or editing, and to hide the code from being viewed. To conclude, let's build a quick test model for our new element. Add a pressure supply and an exhaust from the pneumatics library, and connect the new element. Let's write a formula to change the supply pressure with time, increasing by 1 bar each second. Then we can simulate and view the mass flow rate through the fluid resistance for various pressure differences. The TypeDesigner is a quick and easy way to build your own models and libraries in SimulationX without requiring extensive knowledge of Modelica. To learn more about SimulationX, visit our website via the links in the video description.